So our second lecture for today is going to be actually a very quick lecture because this is just basically focusing on the concept of testing. And we do have a short live demonstration on how can we go about uh, doing testing in particular. 1 second, let me just make sure I have everything set up in the background here. I can show you guys this when we reach this point in the lecture. Alright, nice, everything's set up on my end. Okay, right, everything is right. Okay, all right, so let's start. So, second. Right. Testing here is basically for us to determine if any program meets the required results that we do it, and that everything works as expected. Oh, right, I have a question here. Yes, memorization can also be done for iterations to make it more efficient. Because remember, the concept of memorization is just to make sure that you don't do repeated calculation. Do the calculation once, and you already have the value stored for that calculation, it doesn't make sense doing the calculation over and over again. Just store the result somewhere and just retrieve it afterwards when required. That way you speed up your program, because a retrieval is just like one step in your program as compared to a calculation that may require like 4 or 5 steps. And it uses less memory overall, because for each calculation, remember, that means you need to allocate memory for each one of the variables or each one of the values and so forth, and it keeps on just keep going and going. So it's a nice way of optimizing your programs. Right. So with regards to testing here, testing is just basically analyzing and executing your program to make sure that it actually produces the required results as expected. And this is going to be matching back to your software requirements. I don't know if you actually reach that part in computer systems or software lectures when it actually does start discussing what are software requirements. But when you actually do reach that part, if you haven't, testing is going to play a very important part of validating that your requirements meet the expected specification and that your program works as expected. So why do we test? And it's basically because as humans, we always make mistakes. Part of human nature, you can't avoid that. However, there are some particular mistakes that are very expensive and very dangerous, and you really want to reduce the risk involved in this. So it is always important to test and to find these mistakes early on in your development phase and fix them immediately as required. A good example of this would be a couple of years back, there was a huge recall on Boeing 737 MAX airlines, and it was because of a software problem that they have where the autopilot would have taken control and you could not override the entire thing. So the plane would have just been stuck in autopilot. You couldn't override it, you couldn't fly the plane how you wanted, and so on. That's a huge problem. And they could have identified that problem earlier if they did proper testing procedure. So testing is very important for catching all your errors up front. There are, I will admit, some cases where you do not get all your errors up front, and when you actually have live demonstrations, your errors do occur. That's fine. That's nothing wrong with that. It's anything. You have to always expect the unexpected when it comes to these sort of things. Anything can happen. That's just physical law of nature, if you want to put it that way. When it does happen, it's important that you do take a note of it and you go about fixing it later on, regards to whatever you're doing. So testing is always an important part in your software development process, no matter what. So there are 2 types of testing that can be done no matter what in any process. It doesn't need to be in engineering, it can be in any other sort of field as required. These 2 types of testers there is going to be manual testing and automation testing. I'm going to look at each one of these in turn here. So manual testing, as its namesake says, is just basically trying to do manual analysis of whatever you operate on. And in these particular cases, you're going to have to write out your test plans, your test cases, or your scenarios beforehand and then try to go about executing them one at a time, or trying to observe the code and figure out, okay, how would the code operate if you do particular things as well. There are 4 stages for manual testing, which we refer to as unit testing, integration, system, and user acceptance testing. Unit testing is like the most basic of functions that you may have. Integration testing would be where your functions would be interacting with one another. System testing is if you're testing the program as a whole altogether. And user acceptance testing is basically seeing, okay, how easy it is for like your user to actually use your programs, as well as if your user has any particular difficulties, or if they generate any particular unknown or unforeseen errors from beforehand that unit testing, integration testing, and system testing did not detect. Each testing is done in sequence. So you unit test first, then you go into integration, then you go into system, and then you go into user acceptance. Automation testing is where you use something referred to as automated scripts, and it's possible to use any other type of software to actually run these scripts to test your product or test your program. And it's basically built on the manual process, and instead of you having to go and execute these things one at a time, it's just basically a very fancy way of automating the entire execution process. In programming, automated scripts are mostly referred to as component drivers. Automation, with regards to testing, is actually quite important, in particular for large critical projects where your requirements are basically set in stone, and if they have to change, they are small changes. Large changes. There are large changes. You cannot do automation testing. You're going to have to go back from scratch to manual testing and then formulate the automation testing on top of that. We can classify testing into static testing or dynamic testing. Static testing is where you basically do reviews of your code, you walk through the code, you inspect it manually, and you try to find out any defects or any problems that you have beforehand. In interviews, because you will not be given a computer, you are unfortunately required to know how to static test. And the reason for this being is that your interviewer will want to see how well you can actually spot any particular errors without any assistance, be it from another person or from the computer. So it is a very handy skill to learn how to go about doing static testing. Yes, automated testers may have to refer to things like Cypress for web testing, or they may use external sources as to how to go about doing the testing and so forth, or they can actually write their own automation scripts. And we're going to see later on in this lecture how we actually can write an automation script to test a C++ program. So yes, unfortunately, static testing is something you do have to learn and practice and keep on refining, especially if you do want to get through for a programming job, because this is a skill that is going to be tested upfront. Dynamic testing is where you do have all your full assistance from your compiler, from anyone, and so forth. And you can actually breakpoint and watch your code. You can see whatever errors the compiler will generate and so forth. And you can actually run your code and see how your program operates, expected or not. So dynamic testing is after you write your code and it's time to execute it. You actually do dynamic testing here at this point in time. And this is done before the program is completed in a release to your customer or to your end user. So all those nice fancy tools in your integrated development environment, in this case Visual Studio for C++, you use all those nice fancy tools like the breakpoints, the watch windows, step through, the compilers, the debuggers, and so forth. All those things you end up using for dynamic testing. Okay, right. So, component testing is where we use the same component drivers that we referred to a few slides ago. And these are basically specialized functions that's going to be testing all your other functions within your code. It's also referred to as module testing in some cases. As we saw in our first lecture last week where we did the multiple file structure, and I explained to you guys it's possible to write a component driver in its own individual file and then call it as required. That is where you can actually write your component tests in isolation from the rest of the system. And the cases where you may have functions that have not been fully implemented as yet, you actually can just put like a cout function inside that unfinished function, and you can be like, okay, this function is required to do this, this, and this. And that's what we refer to as a stub, which is basically a placeholder. Say, okay, this is what this function is supposed to be doing, but it has not been completely implemented as yet. So stubs are basically just placeholders for incomplete functions. So, regards to testing methods, we refer to these as the box approach. And there's going to be two box approaches that we use, which is going to be white box testing and black box testing. Now let's look at what each one of these mean. White box testing, as you may think, okay, it's a white box or a clear box. It means that you can see all the code, all the internal structures, all the internal workings of the program itself. So it's not like you're an end user when it comes to testing here. It comes like if you're an actual programmer when it comes to white box testing. So you can see how everything operates, how all the code and variables interact with one another and so forth. And you can see how to go about calling or stringing functions together or different variables and whatnot. Making sure that all your if or else statements are executed, that you may terminate a loop beforehand, you may want certain loops that run fully, and so forth. That's perfectly fine. You have full access to your code. White box testing is used for unit integration and system testing. The advantages of white box testing is that because you're seeing everything, it means that you can optimize and fix your code even more effectively, regardless. The big disadvantage of white box testing is that it's actually very time intensive, and to hire so many people to keep on doing this kind of analysis is actually quite expensive. And it is not physically possible to find every single error during the white box testing program. You actually do have to hand off your program at some point in time. End user, let them use it, let them break your program, record how did they break it, and then go back to the drawing board and fix it at a point in time. This is why programs have release versions. You'll start with like a version 1, then a version 1.1, 1.2, 1.3, because you can't identify every error from the start. Once errors do start happening, you can then fix them on and keep on going on and updating your program. Because you have access to all the code, that also means that the code analyzers and debuggers and all fixing the code. Black box testing is also referred to as specification-based testing. And this is like if you just hand the program to your end user and be like, hey, go and forth and play with this program, break it how much you want, but each time when you break it, record how you went about breaking it so that way I can know how to fix it later. So, as its namesake says, because it's a black box, you can't see the internal workings. All you just see is basically what you input into your program and what the output is. You have no idea how it actually produces those outputs. And black box testing is applied at all levels of testing. So at unit integration system and what we also refer to as acceptance testing, which is our user acceptance testing. The advantages of black box testing is that it's very well suited for any large code segments. You don't need access to the code and get a different view or a different experience altogether from the programmer side, being the developer, and the end user side. Because it may be that, okay, your program is running and whatnot and so forth, but for some instance, your output isn't very user-friendly. And if it's not very user-friendly, your end users may not be inclined to use your program altogether. So this is actually a kind of important part of user acceptance test. The disadvantages of using black box testing is that because you don't have access to everything, you only can do a limited number of tests. And in some particular cases, designing effective test cases are going to be very difficult because you don't have interior knowledge of how the code operates. Now with testing, that means we also need to discuss what type of errors you are going to encounter as well. And there's going to be 3 types of errors, being syntax, logical, or runtime. Syntax errors are normally picked up by the compiler. It's basically something that you may have spelled wrong, if you missed any sort of semicolons, wrong brackets. The compilers will basically flag any syntax errors for you, and your program will not build until you resolve these syntax errors. Logical errors is when your program does build and executes, but it produces the wrong output. The compiler can't detect this for you. In some cases, your program may not crash, but it still produces the wrong output. So when this actually does happen, you're going to have to break out your breakpoints and your watch window and your step-through functions in order to observe step by step what is actually happening and try to resolve the error at this point in time. Runtime errors is when your program runs and then it crashes. In some cases, when it does crash, the program might be helpful and it might throw an error message to indicate some sort of helpful text saying, okay, this is where your program has crashed. And the only way to resolve runtime errors is to know the sequence of steps to produce that error and then try to observe what actually occurs in the code for that particular sequence of steps. And then you can actually analyze your code to see, okay, this is where the runtime error occurs, then you could go about fixing it. So, this code here that I have on the slide is actually for you guys to practice in regards to white box testing. So you have a class function here with its own variables and methods and so forth. And we see the main function here just calls the driver function. This driver function here is going to be our component driver. So I want you guys to actually try out this code when you get some time. And inside of the driver function, I want you guys to write different instances of testing the rectangles and in functionalities to see, okay, what actually does happen if we keep on doing this. And we can see that this single call to the driver function, all we need to do for any white box test is just to keep on adding or removing instructions from this driver function here. And we don't need to modify any other part of the code altogether. Just only the driver function will just be modified for that. So this explanation that I just gave you here is basically on the slides. It's just the driver function that you're required to modify to perform any of the white box testing. And all your test cases and scenarios will just be placed inside that driver function. All the generated outputs will be towards the console stream. For black box testing, you're going to have to implement your program a little bit differently. And typically, black box testing is normally done manually, but it's very time intensive, and it's possible for us to automate this process. So, in doing black box testing, that means you're going to have to rewrite the functionality of your main function altogether. So your main function needs to take this particular instance and this particular format. For this particular format, we're going to be paying attention to the variables that we're going to be using inside here for our inputs towards our main function. In particular, we're going to see that we have argc here, which is just an integer, but we have a character pointer to an array here, in a character array, which is going to be labeled as argv. Argc is going to be keeping track of the number of elements in argv. And argv here is basically going to be a character array that's going to be sourcing from the command line. And we're going to see a practical example of this just now in a few slides, and also live here as well. And the spaces between characters is going to be treated such that it's a separator, between each character cluster, where each character cluster is going to be treated as a separate parameter. So I have some example code here, and if you actually try to build this and run this, you may get an output, but it's not going to make much sense to you. You're going to be like, well, okay, nothing really happened, so why did we have this code to begin with, and what is it actually the purpose? So at this point, we're going to do a live demonstration to show you guys why is this code important, and why do we have this in argc here, this argv here, and what is the purpose of it. I'm going to pull this down here. Visual Studio. So at this point, okay, this might be a little bit too small for you guys, so 1 second. Switch my settings here a little bit. Right. Okay, that should be a little more visual, so we can see what's going on. So we already have our code here inside Visual Studio. And if we build our solution here, we see that everything executes normal. We have no problems. Go debug, start without debugging. Basically say, okay, argc here is going to be 1, but argv here is just going to be a full path where our program is located. And you're going to be thinking of, okay, this already didn't do anything. What is the purpose of this code? The purpose of this code actually is that you need to run this in the command line. So if we go here and if we go in our start menu and let's type in command prompt and let's run this as administrator so that we don't get any problems. Get a command prompt here. Right. If we also go inside where we have our project stored. So in my case, in my documents folder, I have Visual Studio 2019 where my projects are stored, and if I go in projects, the project I created was Sandbox, inside here, and then inside the x64 folder, and then debug. You can see that I actually have a Sandbox application here. So I can copy this part here. I can just highlight this entire thing. I click and copy. I could go back in my command line here. I could type in cd and then just right click to paste part. And then just press enter and we can switch to the part here where our program is located. So I can now type in just sandbox and you see argc1 and argv0 sandbox because I'm executing my program without the use of Visual. But I can type in sandbox 1, 2, 3. And now we can actually see what this program actually does. So we have argc here being equal to 4, but we have argv0 here is equal to sandbox. Then we have argv of 1 being 1, argv of 2 being 2, and argv of 3 being 3. And you may say, okay, well that's 1, 2, 3. Alright, let's change this. Let's say apple, banana, orange. Argc here is still 4, and the reason for this being 4 here is that sandbox, being the name of our program, is our first parameter being stored at 0. So just for simplicity's sake, we're going to be saying this is our 0th parameter. Our first parameter being parameter 1, argv1 is apple. Our second parameter here is banana, and then our third parameter here is orange. So what this functionality of the code does here is allows us to pass what we refer to as command line parameters to our program. And having these command line parameters, it makes automation testing of our programs, regards to black box testing, a lot easier to execute. Anyone a little bit confused or anyone needs any clarification as to why this is being done, please ask so now. Well, it did work before. But remember, all we just got was just the argc0, sorry, argc here equals to 1, and argv0 equals to sandbox. So the code was as expected, but the problem is that we didn't know how it actually operated. This is why I showed you guys how it actually operates and what it actually does. The console wasn't enough because we weren't passing any command line parameters when we ran it from Visual Studio. So if we go back in Visual Studio here, and if we go debug, stop now debugging, we're just going to see argc1 here, argc is equal to 1, and then argv0 is just going to be the path for where our program is itself. And this is because we didn't pass any command line parameters from Visual Studio into our program. The reason why we're using the command prompt here in particular is that now we can actually pass command line parameters into our program. Now, it is possible to pass command line parameters in Visual Studio towards your program, but it's a little more complex, and each time when Visual Studio changes, the process to get to these command line parameters also changes as well. So this is the simpler way to go about doing this. Just use the command prompt, find where the program is located, and just pass your input variables as required. Right, further questions? Yes, so sandbox is basically the name of our program when we ran it. You can use the terminal in Visual Studio to pass inside there, but like I said, each time Visual Studio updates, it always changes something in the background, so it may not work after a certain point in updating. So I'm showing you guys the surefire way here for it to work. So in answer to the previous question, type in sandbox. Basically, sandbox is the name of our program. If I type sandbox1, it doesn't know what that is, because that's not obviously not the name of our program. Sandbox being the name of our program here, anything after that which is separated by spaces is referred to as our command line parameters. Like I can say 1 apple, 2 banana, 3 orange. And that means we have 1, 2, 3, 4, 5, 6, and then sandbox here being 7 parameters in particular. argv0 will always be the name of our program. argv1 here will be 1. argv2 here being our next parameter is going to be apple. argv3 is 2, and so forth and so on as you keep on. Now, one thing to note here, remember that this is being stored in argv, which is a character array. That means you need to figure out how do we switch this from a character array into other data types later on. And when I get back into the lecture slides, I'll give you guys some advice as to how to go about switching the data types as required. Right, so that's the question that I'm going to answer now. How do we automate the work here? So I'm going to pull this down for a little bit. So in Windows, there's something we refer to here as batch scripts. I already have an example batch script here written to show you guys what it looks like. But I'm going to rewrite this to show you guys, okay, I have one here named test. I want to write a new one, and I'm going to show you guys how to automate it. So I can go here and type in notepad Wait, whoops, sorry. I'm going to run this administrator as well. And the same way like how I was typing my commands on the command line here, I can put sandbox 1, 2, 3, sandbox apple, banana, orange, sandbox 1, apple, 2, banana, 3, orange, and whatnot. No. Normally when you save a file here in Notepad, it saves as a text file, right? We're not going to be doing that. We're going to go File, Save As. I'm going to make sure that we're in our folder here with our executable. And instead of saving as a text document, we're going to switch to All Files. And we're going to give this a name, so let's say test2. But the extension that we're going to put is .bat, which is short for a batch file. So remember, we're not going to be saving this as a text document. We're going to go All Files. I'm going to save this as .bat. So we give it a name, test2, and .bat to make sure that it saves as a batch file. And we're making sure that we save this file here where our program sandbox is located. So it will be in the same directory as it is. I'm going to save this here. I want to minimize this, and we're going to see that we have a test2 here in the background. If I pull back my command line here, I no longer need to type sandbox 1, 2, 3 and run at every instance. All I'm going to do here now is just type test2.bat, and we can see that it executes each one of those lines that we just now had from before. So the batch file here will call each one of these lines and execute it in turn for us, and it will automate our testing for us immediately. So let's just add one more line here. Let's say class, students, time. So I'm just editing the file here, which was our batch file. Let's call back test2 here. And we can see that for every instance, we had 1, 2, 3, apple, banana, orange, 1 apple, 2 banana, 3 orange, and then sandbox class students time. And it just basically executes each line for us automatically within the batch file. So this is actually how we go about automating manual testing in C++ and Windows. Alright, any particular questions? So it feeds into your program to do the testing because you can actually accept these command line parameters, you can actually specify in your command line which one of the test cases is going to be executed at any point in time. The command prompt is just going to be responsible for executing your program. So this is like where we were discussing black box testing, that we need to use another particular software to go about testing it and so forth. This is an instance of what we can use in a particular case. So the command prompt here basically becomes the interface to our written program, and we can automate our interface here to produce the required results from our program. just my play here one time. Alright, so in the interest of time, I already got a few more slides, so let me finish this up one time. Right. So, just to recall that because we're using a character array here, remember these are going to be of the char data type. And in some cases, you're going to have to switch this from the character data type into numerical data types if you're passing numbers program from the command line. So there are two functions which you can use, which is going to be a to I and a to f. I want you guys to do a little bit of research as to how these functions operate. And there's a lot of examples out there on how these functions operate. And you're going to find a lot of examples as well with regards to that argc and argv that I just showed you, respect to a to I and a to f. If I do happen to get time, I want to show you guys a very full practical example of why this is important for automation testing. Now, the last thing we're going to discuss here is what we refer to as exception handling. So, exception handling is trying to prevent runtime errors from happening in your code in particular. Now, in our particular case, when we try to divide by 0, you can actually try to catch this or try to check for this using an if statement, but then this is just one case. There are other cases that may cause runtime errors. And every instance when you do that if statement, it's going to keep on inflating your code, because that means your program is going to have to do multiple different checks for each one of these particular errors, and it's going to reduce the execution time. Sorry, it's going to increase the execution time of your code altogether. So exceptions in C++ is like a very optimized way of handling these errors, and you're using special functions called handlers in order to do this particularly. The three keywords that you're going to be using is going to be try, throw, and catch. Try block is going to be what you're going to be encapsulating your code that needs to be analyzed for any runtime. You'll put a throw instruction where you expect the runtime error to occur when a problem actually does happen. And the catch block will just grab the error from the throw and then handle it within your program and make sure that your program doesn't crash. In most cases, the catch block is going to be your exception handler, which is a specialized function. So I'm going to give you an example code here for you guys to try, and for you to actually see how the try block here, the throw statement, and the catch block here operates in conjunction with each one another. So I encourage you guys to try out this code and actually see how it operates. And you can see how the try, throw, and catch here operate with one another. You can then go about, instead of having y equals 0 here, changes to some other value, and you will see that we no longer have to throw this error, and the catch block will not execute altogether because the program runs as expected. So once that exception arises in the try block, I will throw the exception, and the handler, which is going to be the catch block, is going to control that and handle the exception and make sure that your program doesn't crash. If there's no error to begin with, the code is just going to continue as normal, and it's just going to ignore all those exception handlers. So the try, throw, and catch block here is basically a nice safety measure to make sure that your program does not crash unexpectedly. And your program can still execute as normal without having any pauses or having to restart it altogether. That brings us to the end of our testing lecture. And basically what we saw here is that we saw that there's manual and automation testing, that there's static and dynamic testing, then we also saw that there's the black box and the white box approach. We saw in particular that even though static testing is very manual in nature, it's also very important to have this skill for any programming interview. This is what you're going to be analyzed on, because most of the times you're not going to be given a computer. You are going to have to manually analyze your code within it. The only way to get that experience, you have to actually practice and analyze your code. Dynamic testing is when you do have all the compilers and the programs in front of you to actually assist you with finding your errors and analyzing your code, which makes your life a lot easier. But that's actually when you do land the job at that point in time. We also saw that white box testing gave you access to all the code, so you were able to see how everything operated and you can write your own driver functions. And black box testing is where you didn't have access to the code and you just basically acting at the endpoint of a user with just the finished program in your hand. We also saw that instead of having to manually write each one of the cases for the black box, if the program is written specially such that it can take command line parameters, we can then automate the execution of a program using a batch file to run multiple instances, to run the program multiple times, line by line, for each one of our test cases. We finally saw that if we did not want our program to crash and it could still execute, we can use the try, throw, and catch blocks, which is also referred to as exception handling. And if this allows us to make sure that our program does not crash and that it can handle any unexpected errors or any predicted errors that may occur and ensure that our program continues to operate regardless of what happens. Alright, so that brings us up to the end of today's session, and we're basically out of time at this point. So if there are any further questions, feel free to leave them down in the comments below. Or feel free to directly email me and I'll respond to you guys as of such. You can also put a post on the forum and ask anything regarding this. Wednesday session, because we've basically covered the material for this week, is going to be solely focused on the tutorial, and we're going to be addressing each one of the concerns that we saw in last week's lecture and in today's lectures. And we're going to see what happens when we actually start observing this while using our compiler. So we will get to see step by step how recursion works. Why do we do particular steps of our recursion? Like, why do we add that result in our recursive step? We're also going to see how the try, throw, and catch works in a more intuitive fashion. And we're also going to see the importance of having that black box automation testing. Why it is that we need to use that argc and argv in particular, and how it actually plays a very important part for automation. So I believe that's going to be on the first hour of Wednesday, and then the second hour of Wednesday will be with Akash, and he'll be doing the computer systems lecture or the software programming, the software lectures. Not sure what he's doing in the second hour, but he will let you guys know when. So until Wednesday, take care, be safe. I will see you guys soon. Later.